This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. This is a telescoping series, and if we're able to find the limit as it approaches infinity of the sequence of partial sums, then we can say that the telescoping series converges to that limit, if it exists. The sequence of partial sums is literally just you adding up the sums starting from 0 all the way until n. So here we start at 0 because this is 0, then the sum up until 1, which includes the sum of 0, then the sum up until 2, which includes the sum of 0 and 1, and so on up until the last sum, which is n. And then maybe we could also say n minus 1, which is the second to last one, and so on. How would we find a sub n? By literally finding these first and trying to recognize patterns. So this really just says, hey, plug in 0. So here we have 0, we have 4 divided by 1, which is just 4. Here we have 0, and that's 4 over 5. And to keep things organized, keep it in a parenthesis. Then you move on to your next one, so as sub 1. That includes the sum up until 1, so that's the sum up until 0. So this, plus when you plug in 1, you get 3. In 1, you get 7. So 4 over 3 minus 4 over 7. So that's done. And I always try to do at least 4 rounds. So then I plug s sub 2. So that's a sum up until 2, which includes a sum up until 1. So I'm going to drag this down. Then plus, when I plug in 2, I get 4 plus 1, that's 5. When I plug in 2, I get 4 plus 5, that's 9. So 4 over 5 minus 4 over 9. And then my last one is sum up until 4, which includes the sum up until 3. Plus, when I plug in 4, I get 8 plus 1, that's 9. When I plug in 4, I get 8 plus 5, that's 13. So 4 over 9 minus 4 over 13. And then I just look at my last round and I try to identify a pattern. So I see a minus 4 over 5 here and a positive 4 over 5 here. So these cancel out. So this was the last term canceling out with the first term. And I see the same here. This is a last term canceling out with the first term. So that's the pattern. Every time you have a last term, that last term will cancel out with a first term. So if we follow that same pattern, then this last term will cancel out with another first term somewhere along the lines if we keep adding s sub 5, s sub 6, s sub 7, and so on. And this last term will also cancel out with another first term. And so then you ask yourself, what's left? Well, this 4 is left and this 4 over 3 is left. And that makes sense because you're saying that a last term cancels out first term. This is a first term. The only way that this can be canceled out is if there was a last term and there's nothing before that. There is no last term to cancel out with this one. So this just stays there. And this is a first term, and a first term can only be canceled out with the last term, but this last term actually canceled out with this one. So this is already used up, and there's no other last term over here that you can use to cancel out this one. So this also stays. So your s sub n is already equal to 4 plus 4 over 3. And so here's a tip. If you have two things that didn't cancel out in the beginning, then you will have two things that won't cancel out at the end. So just like we started with the first term, n is equal to 0, we could also start with the last term, or end with the last term. So s sub n, right? N is whatever the last term is. And this one's easy. It's literally just this, so copy it. And s sub n includes the sums up until s sub n. So it's dot, 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 and then plus. We could also do s sub n minus 1. All that just means is wherever you see an n over here, do a minus 1. So this becomes 2n minus 1, so multiplication plus 1, distribute 2n minus 2 plus 1, this becomes a minus 1, 2n minus 1. This is a 4, 2n minus 1, and then here we have 2n minus 1 plus 5, 2n minus 2 plus 5, this is a 3, 2n plus 3. So that's the partial sum of s of n minus 1, but it includes all of the sums up until s of n minus 1. So we would just do this, plus, and then remember that we also have to add this because this comes after. Then let's do another one, s sub n minus 2. So just like I started with the first term and then I added 1 to get to the next term, here I started with the last term and then I subtract 1 from that n to get to the second to last term, and then I do 1 again, and so on. So dot, 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 plus, and then whatever this is, and then plus the rest of them. So let me shrink that right there. So here, wherever I see n, I'm subtracting 2. It becomes 2n minus 2 quantity plus 1, 2n minus 4 plus 1. That's 2n minus 3. So that's 4, 2n minus 3. Then again, minus 2, so 2n minus 2 plus 5. That's 2n minus 4 plus 5. That's positive 1, so 2n plus 1. And then to keep things symmetrical, because we did 4 rounds here, let's do 4 rounds here as well. So let's do s of n minus 3. It's going to be dot, 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 plus whatever that is, and then plus whatever comes afterwards. So now wherever we see an n, we do a minus 3, so that is 2n minus 6 plus 1, so that's 2n minus 5. Again, n minus 3, so here 2n minus 3 times plus 5, that's 2n minus 6 plus 5, that's a negative 1, so 2n minus 1. And so now I look at my latest row, and I'm going to attempt to use my pattern. So the last term should cancel out with the first term. So here I see a minus 4 over 2n plus 1, and here I see a positive 4 over 2n plus 1. So again, a last term cancels out with the first term. And then here, last term cancels out with the first term. And then following the same pattern, there will be a last term over here somewhere in like the s sub 5 until s sub n minus 4 that will cancel out with the first term over here. And there will be a last term over here that will cancel out with this first term over here. And then what are we left with? We're left with these. So again, if we were left with two things in the beginning, then we're going to be left with two things at the end. And it makes sense that these are what are left because this is the last term. And the rule is that the last term cancels out with a first term, but there is no other first term after that, so that this cancels out with that first term. So therefore, this can never be canceled out and we're just left with that. Similarly, this is the last term, and so the rule is that a last term cancels out with a first term, and the only other first term that we have after that cancels out already with another last term, so it's taken up. There's nothing that will cancel out this one, and so we're left with this one as well. So our S of n, this whole thing can just be simplified to 4 plus 4 over 3 minus this, because these are the only things that don't ever cancel out. And then to find if the telescoping series converges, you just take the limit of S of n. So you just copy this over and take the limit as n approaches infinity. If you plug in infinity here, this is just going to become 0. If you plug in infinity here, this is just going to become 0, because remember that one whole divided into infinitely small pieces becomes infinitely smaller, so small, it becomes 0, or at least it's being limited to 0, because you can barely see the whole if you just keep cutting it infinitely. So if these go to 0, then you're simply just left with 4 plus 4 over 3, which if you go ahead and add, that is 12 plus 4, which is 16 divided by 3. And so because the limit exists, then we can say that our series, our telescoping series, converges to 16 over 3. And that's it for this video. I'll see you in the next.